Am I audible? Am I audible? Good evening. Am I audible? Good evening, everyone. Welcome to Go Score Learning, the fastest growing edtech company in Middle East. And our main aim is to provide quality education for all. I'm Tanya Rakesh, teacher from the Department of Chemistry, Go Score Learning. Today, I'm here with the Chapter-3 of Grade 12 Chemistry, that is Chemical Kinetics. I know you all are busy with your board exam preparations, your pre-board exams are going at school, and meantime the Christmas celebration, everything is there. You people are so very busy nowadays. Today, anyway, we will cover some important previous year questions from the Chemical Kinetics chapter, which will definitely help for the preparation of your board exam. So, are you all ready? Can we start the session? So, first, I know you all are now aware about the mark distributions, how the marks patterns in the exams, right? So you have 16 MCQ questions and 5 short answer type questions and 7 short answer type questions. 5 very short answer questions which carries 2 marks and 7 short answer type questions which carries 3 marks and 2 case based questions which carries 4 marks each. And finally, you have 3 long answer type questions which carries 5 marks, and together your total score for theory examination is 70 marks, right? So you are already attended the pre-board exams at school, so you know that how the marks distributions, where you are getting more mark, where you have to focus more, and how to distribute the time or manage the time for the exams, that you all are aware, right? So, and also I think you know the mark percentage, the weightage of each chapter, right? And in chemistry for grade 12, the highest mark percentage is for, the weightage is more for the electrochemistry chapter, that you can expect around 9 marks of questions from electrochemistry chapter today. And anyway, we are going to discuss the chemical kinetics chapter, which carries a weightage in terms of mark, that is 7 marks. Okay, and in my point of view, this chemical kinetics chapter, it's a very easy chapter. So if you know the equations and if you are thorough with the concept, you can easily score marks in chemical kinetics, because every concept when compared to other chapter, especially when you compare with the organic chemistry, the chemical kinetics chapter, all the portions are little bit easy to understand, right? If you know the equation of half-life or first order reaction, you can easily substitute their values and you will get the marks very easily. So, don't skip this chapter, as it is a very easy chapter and very easy to understand, and at the same time, you can score marks very easily in chemical kinetics chapter. So, can we move on to some questions from this chapter so that you can revise whatever the concepts, whatever the things, equations that you learned in this chapter. Are you all ready? Can we start the questions? So, your first question is, define the following terms. The first one is pseudo first order reaction and half-life period of a reaction, that is T-half. So what do you mean by pseudo first order reaction? You have an idea what is pseudo first order reaction? So I'll give you the definition. The pseudo first order reaction, it is actually not first order, but it seems to be first order due to some reasons. Okay? So pseudo first order reaction, if a reaction is not, just a moment, if reaction is not truly of first order, but under certain condition become first order reactions. Okay, that is what called pseudo. Pseudo means false. It is actually not a first order reaction, but due to certain conditions, it will follow. It will be seems to be first order reaction. And do you remember the examples of pseudo first order reaction? 2 important examples are provided in your reader that follow pseudo first order reaction, and you should be thorough with that 2 equations. Okay? So let's see what are the two examples for pseudo-first order reaction. First one is the hydrolysis of ester. Okay, so we can take the example of ethyl acetate or ethyl ethanoate. Okay, what is ethyl ethanoate? CH3 COO ethyl group, ethyl ethanoate. Okay, so this ethyl ethanoate hydrolysis, that is treating with water. What you will get? You will get acetic acid or ethanoic acid, CH3COOH plus what? Ethanol, C2H5OH. Okay. So during the hydrolysis of ethyl ethanoate, you will get ethanoic acid and ethanol, and this reaction is of pseudo-first order. Why it is pseudo-first order? Why it is called pseudo-first order? Here you have ethyl ethanoate and water molecules, so definitely it has to follow second order kinetics, right? Why it is pseudo-first order means during the hydrolysis of ester, we are taking a large amount or excess quantity of water. So the reaction, the rate of reaction is dependent on the ethyl ethanoate concentration, and the reaction seems to be, or the reaction will follow first order. That's why the hydrolysis of ethyl ethanoate is known as pseudo-first order reaction. The same one in the case of inversion of cane sugar, which is also another example for pseudo-first order reaction. Okay. So what is cane sugar? It is C12H22O11, right? That also on hydrolysis. That's also on treating with water, you will get, that is inversion of cane sugar, you will get C6H12O6 plus C6H12O6. This is also another example, that is the inversion of cane sugar is also another example for pseudo-first order reaction, and you should be very clear idea about the two examples of pseudo-first order reaction. Okay. Now let's see what you mean by the half-life period of a reaction. From the word itself we will get, right? Half-life period of a reaction. What is actually half-life period of a reaction? It is the half-life, the time taken to reduce the first initial concentration. Whatever the concentration or amount of reactant that you are taking initially, the time required to reduce the concentration to the half of its initial amount. Okay. So let's see, the half-life period of a reaction is the time in which the concentration of reactant is reduced to half of its initial value. That is what called the half-life, and it is usually denoted by T half, the time taken to reduce the half of the initial concentration of reactant. That's what called the half-life of a reaction. So I hope the pseudo-first order reaction and half-life of a reaction both are clear for you, right? So I can see a lot of messages, chat. So Pooja ma'am, Christina ma'am. Okay, thank you all. So we can go for the next question, that is, for a chemical reaction, the reactant is giving the product. The variation in the concentration versus time is given here. So you can see the reactant concentration is plotted on the y-axis, and axis, time, x is plotted on the x-axis, right? So based on this graph, can you just predict which order of the reaction is this? See, here we have taken the concentration of reactant, and here we are plotting it against time, right? And you can see you are getting a straight line, and when you extrapolate the graph, it coincides on the y-axis, right? So you are getting a y-intercept. So just tell me what will be the order of the reaction. What is the order of reaction? This is a graphical representation for zero order reaction, right? This is a zero order reaction. And what is the slope of the curve? What will be the slope of the curve? So for a zero order reaction, what is the equation? R0, initial concentration of reactant minus concentration of reactant at T time is equal to K into T. Right? When you rewrite this equation, you can just write it as RT is equal to, I am taking this on the right side, so it is R0 minus KT. Okay? RT is equal to R0 minus KT. Okay? So, when I am writing this equation in the form of straight line y is equal to mx plus c, I can just write it as RT is equal to mx, that is minus kt, plus your c, the y-intercept is R0, initial concentration of reactant, right? So, when you rewrite the equation in terms of y equal to mx plus c, where m is the slope, what you are getting here? For m, you are getting minus k. So, what is your slope m for this graph? That is minus k, right? Very easy. That's why I told you in the starting session itself, this chapter is very easy. You can easily score marks in this chapter, okay? So, for this question, the order of reaction is of zero order reaction. That is clear from the graph given. And from the graph, when you write the equation and rewriting that equation in the form of a straight line y equal to mx plus c, you will get the slope minus k. So, slope of the curve is minus k. Right? You got 2 marks very easily, right? That's it. So, can we move on to the next question? So, your next question is, for a reaction, 2NH2 gives N2 plus 3H2. Rate is equal to K. Okay? They have given you the rate of the reaction is equal to rate constant K. Okay? Write the order and molecularity of this reaction and write the unit of K. So, can you just say which one is what is the order and what is the molecularity of this reaction? Just comment your answer. If you know the answer, just comment the answer. Oh, I can see a fancy count here. Wow, that's great. So, what will be the order of reaction? See, here it is clearly mentioned that rate is equal to rate constant. What it means? Your rate of the reaction is not depending on the concentration of reactant, right? Your rate is independent of the concentration of reactant. If your rate of reaction is independent of concentration of reactant, what will be the order of reaction? Yes, exactly, your order of reaction is zero order, right? Whenever the concentration term, see, rate is equal to K into any concentration of reactant with term raised to 0, that is what? 1, right? So, your rate will be equal to rate constant into 1. That's what given here. Rate of the reaction is equal to rate constant. So, what will be the order of reaction? Your order of reaction is zero order, right? So, the given reaction is a zero order reaction. And what is the molecularity of this reaction? What do you mean by molecularity? Is molecularity and order both the same? No, right? Molecularity is simply the number of molecules that actively involved in that reaction, right? So, what is the reactant here? You have 2 NH2 molecules, right? So, what is the number of molecules? Or what do you mean by what is the molecularity of this reaction? Yes, the molecularity is 2 and the order of reaction is 0. You have 2 molecules here. So, the molecularity of reaction is 2 and as the rate of the reaction is independent of concentration of reactant molecule, their order of reaction will be zeroed. Right? You got it? So, write the unit of K. So, what will be the, do you remember that formula or a trick to remember your unit of the rate constant? You have mole raised to 1 minus n, liter raised to n minus 1. Second inverse, this n is the order of reaction. You can just simply substitute that values there. Right? So here the n order of reaction is 0 order, right? So when you give mole raised to 1, liter raised to minus 1, second inverse. This is what the unit of rate constant. Okay, you can just note it down. This is the easy way to write the unit of rate constant. Okay, so whatever the order you are getting, substitute that order n value here. So you will get the unit for the rate constant K. Okay, that's for this question. So we can move on to the next question. So a first order reaction. A first order, just a moment. A first order reaction is 75% completed in 40 minutes. Calculates its half-life. And they have given you the values for log 2 and log 4. Okay? So, a first order reaction is 75% completed in 40 minutes. You want to calculate the half-life. So what are the main points in this question? See, they have given you it is a first order reaction and you want to find out the half-life, right? So what is the equation for finding out the half-life of a first order reaction? The half-life of first order reaction, T half is equal to 0.693 by K, right? And it is given that in the reaction 75% completed in 40 minutes. Okay, so your 75% of the reaction gets completed in 40 minutes. Okay, so you want to find out the half-life, T half. Okay, how will you find out the T half for this reaction? It's very easy, right? So just simply by substituting the values. So you know that for a rate first order reaction, the equation is K is equal to 2.303 by T log concentration of R0 by RT. Is it? So we can, from this equation we know the time taken is given 40 minutes and initial concentration, it has completed 75%. So your initial concentration value, if you take 100, or you can here use the equation K is equal to 2.303 by T log A by A minus X. So your initial value, it is 100%, A minus X, 75%, X is 75%. So 100 minus 75, you will get that 25, right? So K is equal to 2.303 by time given is 40 minutes and log 100 by 25. That is log 4 value. Okay, log 4 value already given in the question. Substitute that values, and when you substitute those values, you can multiply and you will get the K value, right? So from those values, once you get the K value, just simply substitute that K value in the equation. You can easily find out half-life of the reaction. See, if you know the equation where you want to substitute, what is the rate or equation or what is the half-life of reaction, these equations, if you are thorough, you can, the values will be given in the question directly. You just want to substitute that values. That's it. Okay, see how easy it is. If you wrote this reaction and substitute the values, and once you get the rate constant K value, substitute that K in this half-life equation, you will get the answer. Try to solve this question and write your answer in the comment box. Okay? So, your next question is, okay, a first order reaction has a rate constant of 0.0051 minute inverse. If we begin with 0.1 molar concentration of the reactant, what concentration of reactant will remain in solution after 3 hours? See, this is also a first order reaction, right? And its rate constant value it is given, that is K is equal to 0.0051 minute inverse. If we begin with the concentration, that is the initial concentration is given here, that is R0. Taking the initial concentration of reactant as R0, that is 0.10 molar. And what concentration of the reactant will remain? So you want to find out the concentration of reactant after T time. That is after 3 hours, your time is 3 hours. When you convert it into 3 into 120, sorry. Into 60, that is 180. Okay? So, what do you want? The anti-log value is given. You want to find out the RT. What is the equation? The same equation that we discussed previously, that is K is equal to 2.303 by T log R0 by RT. This RT is what you want to find out, right? And the K value it is given, time is also given, substitute that values. K is equal to 0.0051 into time is 180 divided by 2.303, which is equal to log of R0 value is 0.1 divided by RT, right? So, after doing the calculation, you will be getting this value for this calculation. That's what the anti-log is given there. So, 3.398, okay, is equal to log of 0.1 divided by RT, okay? Now, see, how will you find out 0.1 divided by RT? That is anti-log of 0.398. What value is given here? What is 2.503? 2.503 is equal to 0.1 divided by RT. Then what will be RT value? That is the concentration of reactant after T time. That RT is equal to what? 0.1 divided by 2.503. So what will be your answer? RT value, if you do the calculation, 0.1 divided by 2.303, you will be getting around 0.0399 molar, which is approximately equal to 0.04 molar. Okay, your final answer will be, you should get, after doing the calculation, you have to get the answer 0.0399 molar. That is what the amount of reactant that remain after 3 hours. Okay, so see, the equation that you have to use is the same. The first order reaction rate constant equation, K is equal to 2.303 by T log R0 by RT, and substituting all the values given, you can easily find out the concentration of reactant left after 3 hours. Okay, so done. So can we move on to the next question? So your next question is, the rate of a reaction becomes 4 times when the temperature changes from 293 Kelvin to 313 Kelvin. calculate the energy of activation, that is EA, energy of activation of the reaction, assuming that it does not changes with the temperature, and they have provided you the R value, that is 8.314 joule per Kelvin per mole, and the log 4 value is also given in the question, that is 0.6021. So what do you want to find out? The energy of activation. So what is the equation for finding out the energy of activation? EA. Do you remember that equation? You have log K2 by K1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. Is it? And all the values are given in the question. So by simply substituting itself, you will get the answer. See, the rate of the reaction become 4 times when the temperature changes. So if you are taking your initial rate constant K as equal to K1, so your K1 is equal to K, your rate constant changes to 4 times. That means what will be the rate constant? K2, 4 times the first rate constant K, right? So your K1 is K and K2 is 4 times the K. Okay. And what are the temperature given? Your initial temperature T1 is 293 Kelvin, and your temperature T2 is 313 Kelvin. Okay. And also the R value, it is given in the question, 8.314. You want to find out the activation energy. See, if you know this equation, this is the equation for finding out the activation energy. Just you need to substitute that values and do the calculation. You will get the answer. That's it. See how much simple it is. See, log K1, your K2 is 4K. Log 4K by K is equal to EA by 2.303 into R is 8.314. 1 by T1 value is 293 minus 1 by 313. Right? So when you do the calculation, this K and this K get cancelled, right? So log 4 value, it is given in the question, that is 0.6021 is equal to EA by 2.303 into 8.314 into, what will be the value here? 313 minus 293, right? You will be getting 20 divided by 293 into 313. Okay. So, what will be your activation energy value? I will write here. Okay. Otherwise, I have to change all the values to the next slide. So, your activation energy EA is equal to, I am taking all these things to this side, that is 0.6021 into 2.303 into 8.314 into 293 into 313 whole divided by 20. So once you do this calculation, you will get the answer, and after doing all the calculation, just try to solve this equation. So find out this multiplication and divide that answer. Your final answer should be 52.86 kilojoule. Just try whether after doing the calculation, do you get this final equation, that is EA is equal to 52.86 kilojoule. Okay. So this is the equation how to find out the activation energy. Okay. So just remember, this is a very important equation. You can expect a question like this, activation energy. Either they will provide the activation energy and they will ask you to find out the temperature, or they will provide all the values K1, K2, T1 and T2, and you have to find out the activation energy. So keep in mind that your equation to find out the activation Energy is log K2 by K1 is equal to EA by 2.303 or 1 by T1 minus 1 by T2. Okay. So can we move on to the next question? Are you all ready? So your next question is, it's same like that. I'm not going to repeat this question again. You can do it by your own. The same type of question. For a decomposition reaction, the values of rate constant K at two different temperatures are given below. That your K1 is given directly there. 2.15 into 10 to the power minus 8 liter per mole per second at temperature 650 Kelvin. So your T1 value is 650 Kelvin and your K1 value is also given. In the K2 value is 2.39 into 10 to the power minus 7 at temperature 700 Kelvin. That is T2 is equal to 700 Kelvin. Calculate the value of activation energy for this reaction and R value is also given. So using the same equation that we discussed for the previous question, you can easily find out the activation energy. So just write down this question and do it by your own. Okay, I'm not going to repeat this again. Okay. Can I change? Okay, we can go to next question. So it's an MCQ question. Okay, so which of the following expression is correct for the rate of a reaction given below, and your equation is 5Br minus plus BrO3 plus 6H plus gives 3Br2 plus 3H2O. So first we can write down the rate equation for this one. See how we can write. So whenever there is a coefficient, you have to take the reciprocal of that one, right? So whenever there is a coefficient for the reaction, you have to take the reciprocal. Okay, so see what will be that value. Since it is a reactant molecule, you have to take the negative value, right? Because as the reaction is proceeding, the concentration of reactant get reduced. So that reduction in the amount of concentration, that's what we are representing with the negative symbol. Okay, so here the coefficient is 5, so you have to take minus 1 by 5. Okay, concentration of Br. Okay, change in concentration of Br with respect to change in time is equal to, for BrO3, since there is no coefficient, we can just simply take it as minus change in concentration of BrO3 with respect to time is equal to, for hydrogen ion, the coefficient is 6. So when you take the reciprocal, it is minus 1 by 6. Minus 1 by 6 delta T. So see in this option, they are comparing for Br minus and H plus. So when you take this two together, so we will be getting what? 1 by side. So it's all negative. So I'm cancelling the negative value. 1 by 5 delta change in concentration, right? Of Br minus delta T is equal to 1 by 6 So now see delta Br by delta T. So when I take this 5 on the side, you will be getting 5 by 6. Right? So which one is the answer? See delta Br by delta T is equal to 5 by 6 delta H. So your answer is third one. See, the only thing that you have to keep in mind is that whatever the reaction it is given, if there is a coefficient, you have to take the reciprocal of that one. And if it is a reactant molecule, definitely you have to put a negative sign to indicate the decrease in the concentration, and if it is a product side. So if you are writing in terms of Br2, your answer will be 1 by 3 concentration of Br2 by delta T. So by simply doing that one itself, you can easily find out the answer for this MCQ question. Okay, so now we can move on to the next question. In a reaction A plus B gives C, the rate expression is given as R is equal to rate constant K into concentration of A into concentration of B square. If the concentration of both the reactant is doubled, so you are doubling the concentration of both reactants. So your concentration of A changes to 2A and concentration of B changes to 2B. You are doubling the concentration of both the reactant. Okay? If the concentration of both the reactant is doubled at a constant volume, then the rate of the reaction will be how the doubling the concentration of reactant affect the rate of the reaction. See, nothing to do, only just substitute. Instead of A, substitute 2A. Instead of concentration of B, substitute 2B. So what will be the change happening there? Rate R is equal to K into, for A it is 2A and B it is 2B. 2B raised to 2, right? That is 2B whole square. So what will be the value you are getting? K into 2 into concentration of A. 2 square is 4 into concentration of B square, right? So I am taking the number together, that is 4 2s are 8 into K into concentration of A into B square, right? So your new rate constant R dash or R naught is given by is equal to 8 into your first concentration R. So when you double the concentration of both the reactant, what happened for your new rate of the reaction, it get increased by how many times? 8 times, right? So which one is your correct answer? Is it doubling, 8 times, quadruples or triples? Your correct answer is, it is the new rate constant. The new rate of it, the new rate of the reaction will be 8 times increased, right? So I hope this concept is clear. So whenever you get the rate expression, just write it, and when you are doubling or tripling, whatever it is doing, just write here and substitute that values. You will get a new rate reaction, and just relate that reaction to the given equation. If it is doubling, quadruples or increasing by 8 times, whatever it is, you can easily find out. Okay, that's for this question. So when we move to our next question, calculate the overall order of a reaction which has a rate expression. Rate is equal to K into A raised to 1 by 2 into B raised to 3 by 2. What do you mean by order of a reaction? How will you find out the order of reaction? Order of reaction is nothing but the sum of the exponents, right? Sum of the powers, not exponents, sum of the powers in the rate expression, right? So if you have a rate expression, R is equal to K into A raised to X into B raised to Y, what is the order of this reaction? The order for this reaction is simply the sum of the powers, that is X plus Y. Okay? So if you know this, just tell me what is the order of this reaction. Nothing to do, just simply add the powers of the concentration terms in the rate law or rate expression, right? So for the first equation, rate is equal to K into A raised to 1 by 2 into concentration of B raised to 3 by 2. Your order will be equal to, order of reaction is equal to 1 by 2 plus 3 by 2, that is 4 by 2, which is equal to 2. Your order is second order reaction. And what about the second question? That is, order is equal to, here it is, A raised to 3 by 2 and B raised to minus 1. So when you add 3 by 2 plus minus 1, that is equal to 3 minus 2 by 2, that is, that is 3 by 2, 3 minus 2 by 2, that is equal to 1 by 2. Your order of reaction is 1 by 2. See how easy it is. Okay, I just fixed it. Okay. Can we move to the next question? The reaction A plus B gives AB has 0 order. So, write the rate equation. So, as I told you previously, if it is a 0 order reaction, what do you mean by 0 order reaction? If the rate of reaction is not depending or independent of the concentration of reactant, that type of reactions are called 0 order reactions, right? So, for a 0 order reaction, if this reaction follows 0 order, what will be the rate? Rate is equal to rate constant K. Since it is a 0 order reaction, it's not depending. So 0 order means A raised to 0 into B raised to 0. Then only you will get the order 0. 0 plus 0, 0 value, right? Any number raised to power 0 means it is 1. So your rate is equal to K into 1 into 1. That means your rate is equal to K. Okay? So, that's about this question. So, when you calculate the order of reaction, there is nothing to do. Just add the sum of the powers of the concentration terms in the rate equation. And for the reactions for 0 order reaction, it simply indicates that the rate of the reaction is not depending on the concentration of the reactant molecule. Okay, so I hope this is clear for you. So when we move on to the next question, the rate constant for a first order reaction involving a compound A was found to be 0.082 minute inverse. When the initial concentration of A is 0.15 mole per liter, how long it will take for the concentration of A to drop to 0.03 mole per liter? Just read the question carefully. So they have given you the reaction is of first order, right? The reaction is of first order and it involves compound A, its initial concentration. Its rate constant of the reaction is given in the question, that is K value. The K value is given, it's a first order reaction and its K value is given as K is equal to 0.082 minute inverse and the initial concentration of A, that is A naught, is equal to 0.15 mole per liter. And you want to find out the time, how long it will take for a concentration of A to drop to 0.03 mole per liter. So you want to find out the time taken for reducing the concentration of A to reduce the concentration of A to 0.15 mole per liter to 0.03 mole per liter. And they have been given you the log values 2, 4 and 5. Okay. So how will you find out? It's a first order reaction, right? So by using the equation, A is equal to 2.303 by T log R0. Here I am taking A. So A0 by AT. So simply by substituting all these values, you can find out the answer, right? So here K value it is given, the time, that is what you want to find out. So you can just rewrite the equation. You can rewrite the equation as T is equal to 2.303 by K log A naught value it is 0.15 divided by 0.03. Okay. So you will be getting log 3 here and log 3, log 5 here and log 5 value. It is given in the question, that is 0.6989. So simply by substituting values, 2.303 by k is 0.082 into log 5 value, it is given 0.6989, right? So by substituting the values, you will be getting the answer. And after doing, just do the calculation and tell me what is the answer that you are getting here. So after doing all the calculation, you have to get an answer 19.62 minute. Okay, just check whether you are getting this answer or not. Okay, so these all are the equations. If you know this, see, we have done a lot of questions with the same equation, that if you know this equation and if you know whatever the values that given in the question, if you could take it out and substitute that values, you can easily find out the answer. Okay, so can we move to the next question? So your next question is, the decomposition of N2O5 at 318 Kelvin according to the following equation follows first order reaction. And they have given you the reaction, and the initial concentration of N2O5 was 1.2 into 10 the power minus 2 mole per liter, and that after 60 minutes was 0.2 into 10 the power minus 2 moles per liter. Calculate the rate constant of the reaction at 318 Kelvin. This is also of the same type that we discussed, right? So nothing to do. They have given you the initial concentration R0 and after 60 minutes. So the time is also given and final concentration is also given. You want to find out the rate constant K. That's equal to 2 points. So first order reaction, right? So 2.303 by T log whatever your initial concentration divided by final concentration. So by substituting the values, you can easily find out the answer, right? So just do the calculation and comment your answers in the comment box. Okay? So just note down the question. Let me check your comments. Yeah, I can see a few answers here mentioned. Yes. Very happy to see that you people are getting the answers. It's all very easy, right? Okay. So you want a difficult question. These all are very easy type. Okay. So for the next live, definitely we will be coming with, these all are previous year questions. That's why we are discussing these questions today. So next time we will be definitely coming with very tough questions as per your request, okay? Okay. Okay. So next one is, the half-life period of a reaction of first order is 100 seconds. Calculate its rate constant. So the half-life of the reaction, it is given and it is a first order reaction. Again a very easy one. T half, it is given 100 seconds and calculate its rate constant. So for a first order reaction, T half or K is equal to, T half is equal to 0.693 by K, and by finding out, substituting the value of T half, you can easily find out the rate constant, right? A first order reaction has a rate constant of 10 the power minus 2 second inverse. How long will it take for a 20 gram sample to become 5 gram? So what will be? For a first order reaction, the rate constant K, it is given, that is 10 the power minus 2 second inverse, right? So how long it take for a 20 gram of sample to become 5 gram? So how long it will take? So for a 20 gram to 10 gram, that means it's half life, right? Half of the initial value. So from 10 to 5 gram means another half life. So by substituting this, this is a first order reaction, right? So T half is equal to 0.693 by K. So by substituting this value, you will be getting a half life. Its double value, whatever you are getting, T half, its double value will be the time taken for the 20 gram of sample to become 5 gram. Okay, you can easily find out it, right? Okay. Then your next question is, a first order reaction is 15% complete in 20 minutes, and how long will it take to be 60% completed? So how will you do this one? So a first order reaction is 15% complete in 20 minutes. So we can use the equation. It's a first order reaction. So you can use K is equal to 2.303 by T log A by A minus X, right? And its T value, it is given A 100, 100 minus 15, right? And how long it will take, how long you want to find out the time taken. So from this one, substituting this 15% in 20 minutes, you will get the rate constant value. And by substituting that rate constant value, you can find out the time for 60% completion. That time is equal to 2.303 by K value you will be getting by substituting that values, and a log A 100 by 100 minus 60, 40. Okay, A by A minus X. So just try to solve this. This is also simply substituting that value, and log value it is given in the question itself. Okay. And next one is for the reaction H2 plus Cl2 giving 2HCl. The order of reaction. What will be the order of reaction? See, it's a photochemical decomposition, right? Sorry, it's a photochemical reaction, not decomposition, sorry. It's a photochemical reaction, right? It's taking place in the presence of light. So since it is a photochemical reaction, what will be the order of reaction? The photochemical reactions follow zero order. Okay, so your correct option is option B. So I think this question that you already know, so that the first order reaction time required for completion of 99%, that is T is equal to 2.303 by K into log A 100 by 99% means 100 minus 99, right? So you will be getting it as 2.303 by K log 100 by 1, that is 10 square. So you will be getting 2 into 2.303 by K log 10 is 1, right? So what is the twice the time required for 90%? So for 90%, T is equal to 2.303 by K log 100 by 100 minus 90. That's equal to 2.303 by K into log 100 by 10, that is log 10. So 2.303 by K. This is for 90% and this is for 99%. Okay. So from this one it is clear that for 99% it is twice, right? Okay. So I have only two more questions. So how the rate of the reaction will be affected? This is a previous year question, that when you increase the surface area, definitely the rate of reaction will be increased. And what happens when you decrease the temperature? When you decrease the temperature, the rate of the reaction also decreases, right? So what happens when you add a catalyst in a reversible reaction. So we know that the catalyst which increases the rate of the reaction. So when you add catalyst in a reversible reaction, the rate of the reaction is also get increased, right? So it's a 2020 previous year asked question. See how easy it is. Okay, and your last question is, a reaction is so first order in A and second order in B. Write the differential equation. See, rate is equal to K into A raised to 1, B raised to 2 because it's of second order, right? How is the rate affected when the concentration of B is tripled? What happens for the rate? Rate is equal to K into A square, B is tripled, 3 B square. So what happened? Your rate will be increased by 9 times, right? So this question already we discussed previously, right? See, it is again repeating. So it's both the concentration of A and B doubled. What happens if you increase the concentration of A and B, double the concentration? Your rate of the equation will be 2 into 2 square. 4 2s are 8 times. It increased by 8 times. See? So today we have discussed very few easy questions from chemical kinetics. So I hope this is clear for you. And we will be coming with some tough questions from this chapter in our next live. So for getting preparation for your exams, please stay tuned with Go Score. Okay? So, as it is mentioned, there is no secret for success. It is the result of your preparation, hard work and learning from your failures. So do your hard work and prove your results. Prove that's hard work or prove your dedication or whatever the effort that you put. Just prove it in your board exam result. So for all the helps and for getting any tips, Go Score will be always with you. So that's all for today. Thank you all.